Today we're going to be talking about the Pythagorean theorem and its converse. Now the Pythagorean theorem is something we looked at back in algebra, and what it was is it said if we have a right triangle, each right triangle has two legs, just like we have two legs, and a right angle that's right between those two legs. Today we're going to be talking about the Pythagorean theorem and its converse. Now the Pythagorean theorem is something that we looked at back in algebra, and what it said is if we have a right triangle, each right triangle has two legs, just like we have two legs, and a right angle that's in between those two. Now, across from that right angle is the side called the hypotenuse. And many years ago, a Greek mathematician named Pythagoras actually saw that there was a similarity between all right triangles and the hypotenuse. And what he found was that if you had a side A and you squared it, and then added it to another leg, side B, and squared that, it was equal to the length of the hypotenuse squared. And we end up getting this equation. It's one of the most common math equations that you'll ever see. A squared plus B squared equals C squared. So we can use that to find our hypotenuse, and actually we can use it to find any length of the legs. So if I look at example 1, it says that I have one leg that's 6, we'll call that A, one leg that's 15, we'll call that B, and then we have the hypotenuse C that we don't know. So we'd say A squared plus B squared equals C squared. So plug in the numbers that we know. 6 squared plus 15 squared is going to be equal to C squared. Well, 6 squared is 36, 15 squared is 225, and C squared is what we don't know. We add those together, 36 plus 225 is going to be 261, and that's equal to C squared. Now we're not wondering what C squared is, we're wondering what C is. So what we're going to do is we're going to take the square root of 261, and we find it to be 16.2. Now you might notice that the hypotenuse is now the longest side, and that is true for all right triangles. The hypotenuse across from the right angle is always the longest side. So if you look at letter B, now if we look at letter B, you'll see that X right here is not the hypotenuse. Rather, it's one of the legs. So we'll call that A. We know that side B is 9, and the hypotenuse C is going to be 11. So I've set up my equation the same way. A squared plus B squared equals C squared. Except this time I don't know what A is. I do know that B is 9 squared, and I know that C is 11 squared. I don't know what X squared is. 9 squared is 81, and 11 squared is 121. I subtract 81 from both sides, and I find that X squared is equal to 40. Now again, we don't want to know what X squared is, rather we'd like to know what X is. So X is going to be the value 6.3. And you'll see again, it's one of the legs, so it's less than 11. Here are two guided practice problems. Feel free to try those now. Now there are some common Pythagorean triples. Those are ones that work as whole numbers when you put them into A squared, B squared, and C squared. And they are most commonly of the ratio 3, 4 to 5. So you'll see that we have 3, 4, 5. If you multiply it by 2, 6, 8, 10, 9, 12, 15, and so you have this as well. There's also this set of triples, 5, 12, 13. Again, you can multiply it by 2, by 3, or by x, and it remains true. Here's the next one, 8, 15, 17, and finally the last one, 7, 24, and 25. Those are all 4 common Pythagorean triples. You should probably make note of those now. It says use a Pythagorean triple to find the value of x and explain your reasoning. So right now it says we have one leg that's x, one that's 12, and my hypotenuse across from the right angle is 15. So I look back onto the last page to see what my Pythagorean triples were that had one leg is 12 and the hypotenuse 15. Well, it doesn't work out nicely for any of the Pythagorean triples that they listed, but it does say that the original one, 3 to 4 to 5, if I multiplied it by 3, I'd get 9 to 12 to the hypotenuse of 15. So what's the missing side? It's going to be 9. And you could solve it the same way we did example 1. Here is some guided practice problems. You can try those as well. Example 3, it says, Damon is locked out of his house. The only open window is on the 2nd floor, which is 12 feet above the ground. He needs to borrow a ladder from his neighbor. If he must place the ladder 5 feet from his house to avoid some bushes, what length of ladder does he need? So you'll see right here, 12 feet, 5 feet. We're looking for the hypotenuse of a right triangle. So again, this is actually one of our Pythagorean triples, and that was 5 to 12 to 13. So without having to even put it into our Pythagorean theorem, we know that the length of that ladder is C, 13 feet. Here's an example as well. It says, according to your company's safety regulations, the distance from the base of the ladder to the wall is that it leans against and should be 1/4 of the ladder's total length. You are given a 20-foot ladder to place against a wall at a job site. If you follow the company's safety regulations, what is the maximum distance x up the wall the ladder will reach to the nearest 10? So the information that they don't give us on the picture, but what they tell us in the problem, is that they want this to be 1/4 away from the length of the ladder. So that's going to be 5 feet right here. And so x is my other leg, and I need to figure out then from this how tall it's going to reach from the ladder. So what I can do is I can say 5 squared plus x squared is equal to 20 squared. Fill in the numbers you know. This is 25 plus x squared, and 20 squared is 400. Subtract 25 from both sides, and I find that x squared is equal to 375, square root that, and I find it to be 19.4 feet is the length of x up the wall. Now the converse of the Pythagorean theorem says this. If we know that a squared plus b squared equals c squared, then it is a right triangle. So we can use this to figure out if something is a right triangle or not. The next theorem, 8.6, says that if c is less than a squared plus b squared, then it's an acute triangle. So think about it. Less, smaller, acute, small angle. And finally, the next one says if c squared is bigger than a squared plus b squared, then it's obtuse. So again, if c squared is bigger angles, obtuse angles. That's how I remember them myself. So if I look at example 4, when we had to classify this, it says determine whether each set of numbers can be the measure of the sides of a triangle. If so, classify the triangle as acute, right, or obtuse, and justify your answer. Now if you think back to earlier in one of the chapters, it talked about that the two sides of a triangle, when they're added up, must be bigger than the third side. So if I look at the first two, 7 plus 14, is that greater than 16? It is. It's 20. Then I look at the next two, and I say, okay, well, 7 plus 16, is that greater than 14? It is. And I look at the last one, and that says 14 plus 16, and is that greater than 7? It is. So this is a triangle. Now what we need to figure out is whether it's acute, right, or obtuse. So I say 7 squared plus 14 squared, and I put 16 squared over here. Well, 7 squared is 49, and 14 squared is 196. Add them together, and it's 245. And 16 squared is 256. So is 245 bigger or smaller than 256? Well, since it's smaller, c squared is bigger, thus making it an obtuse triangle. Just like I said before, bigger side, c is bigger, c squared is bigger side, bigger angle, obtuse triangle. Let's look at letter B. Now in letter B, 9 plus 40 is greater than 41. Check, that's correct. Let's go to the next one. 9 plus 41, bigger than 41. Bigger than 40? Check. Last one. 40 plus 41. Bigger than 9? Check. So this is a triangle. Now we need to figure out if this is a right triangle, acute triangle, or obtuse triangle. So 9 squared plus 40 squared. And then we have 41 squared over here. Well, 9 squared is going to be 81. And 40 squared is going to be 1600. So together this is 1681. 41 squared is 1681. They are equal. So this is a right triangle. Here's a couple guided practice problems. Remember, you should check to see if the sides are worked to be triangles before you figure out which type of triangle they are.